this before. Okay. So today we'll be doing a lecture on Introduction to Performance Testing. We will get into the nitty-gritty and what we will be covering very soon. I would first like to start off this lecture with a personal story, something that we went through due to not having performance testing, and I would like to lead a bit with that. So as you can see, I have this little cloud image design here on the screen, which shows a 503 error. We've already covered those as the gateway timeout, meaning that something's wrong with the application. And why did I decide to go with this and share this story? I want to highlight why it is important to practice performance testing. So to fill you in shortly, performance testing is something that's I would say relatively new as a concept in testing in general, and not just recently, but in some past years, it has become more of a trend to practice it in comparison to the distant past, let's say. And I would also say fortunate and unfortunate to be on a project that saw the backlash of not having performance testing. So what happened was we were working for a non-government organization, which had like I would say, had a website that researchers and scientists used to publish or look for publications for some papers, so on and so forth. So there was not a lot of traffic ever happening. I mean, in comparison to other services. And the team that was there before I joined, and as well the clients, they thought that performance testing is not needed because it's not a big application. And then one time we were doing a feature which was used to help the learners and the scientists to be able to cast their votes and look for candidates for something that they decided to create from that year on, which was an event where researchers were giving awards, honors, basically. And nobody really expected there to be a spike of users specifically for that new event. And what happened was we tested everything. So functionally, everything was working perfectly. We had everything deployed. Everything was on production. So we already passed every environment. We went through stage. We went through development. So everything was live. And as we do the launch, so everything goes through, 30 minutes pass, and then we get this gateway timeout. So nobody can reach the page. Then we get a bad request. The page crashes totally. So the clients are all in their head. They're very stressed. We are stressed. Everybody's stressed because nobody can reach the page and cast their votes. And basically, we had this enormous issue of not being able to reach anything, whereas the people are supposed to be using the page. And then after 5 hours of debugging, we found that this was a performance-related issue caused by a leak of data and the amount of users that were absolutely not expected to visit the page at that time. So we resolved it, but lessons learned. And then we had a bit of a hard time of getting a renewal of the contract. So not having covered this at that time caused us to basically lose trust and then need to build it up going onward. But again, very stressful. I don't recommend it. And that's why I want to highlight why it is important to do performance testing. So basically, that is the topic that we will be discussing in today's lecture, performance testing. So I'm going to move back to the materials. Basically, the importance of performance is on the same level of functional testing. So when you have an application, web page, however you want to phrase it, it's not only that you cover every functional aspect and you're good to go. You have to make sure that non-functional aspects work as well. They're as important as the functional aspects because although the user interface and backend are very, let's say, applicable to the user experience, because again, that's what they interact with, it is very important to make sure that what they get as information is in a timely manner and can serve every individual user without any flaws. So without any delays, without any crashes, so on and so forth. And that's why we as testers have this duty of making sure that our page performs to the best of its abilities. So without further ado, we will be diving into performance testing, and we can expect to get an understanding of what are some of the fundamentals and why performance testing is important, see what are the different types, because often some people just think performance testing is just one type of testing, when in actuality is a larger group. Understand the process of what goes on during the performance testing process, learn about key performance indicators, what do they mean, how can we understand to read and note down data from them, and see some testing tools, which we will also use in the hands-on lecture later next week, and also see some of the concepts in action in one of the lab exercises. So without further ado, let's move on into the first section for today. So what is performance testing? You might remember that we were discussing the testing types in one of our earlier lectures. And as I mentioned there, it is a type of non-functional testing. So we're not focusing on modules, on functionalities, integration. We're just making sure that the application is working based on its performance, on its scalability, on its stability, on its responsiveness. So aspects that are not tied to the functionality of modules. So that's why we refer to it to non-functional testing. And as I mentioned, it is on the same scale of functional testing. One cannot go without the other, even if you have the most lightweight application at your disposal. Remember that performance testing should always be practiced. Now, regarding what are the more, let's say, the biggest objectives of performance testing. Well, one of them is evaluating speed, as you can see here. So this is basically telling us how fast does the application respond. So imagine you're using Facebook, you try to log in. So if you wait for 5 minutes, you would most likely be frustrated because, again, it should not take that long for you to log in. Or when you're trying to search for a user, you want to get the result ASAP. So this is one of the aspects that you test when you're performing such scenarios. And we will see later on, so you can actually apply performance testing to various let's say, module groups. So it's not only that you work on the page and isolate the modules directly. Assessing scalability. So you want to make sure that the application can handle different sets of loads over time. So maybe sometimes the application has to increase tenfold. Sometimes it might need to downgrade fivefold. So you want to make sure that those scenarios are all well maintained and can take in all those users and traffic. Stability. So again, when we check non-functional aspects, one of the key aspects is stability. We want to make sure that whatever happens with the application is in a very good flow. Meaning, let's say you have 10,000 users at one time, then you have a million users at another time, maybe you have a spike of 3 million users, then you want the application to perform the same way it did for other users. So this is a very important aspect of it. This also includes checking some load balancers, like different servers that handle the application. This is more in depth, but it refers to that as well. Identifying bottlenecks. So what components or what processes slow down the system. Maybe you have some, I would say, let's say a header image module, and the image is in a JPEG format, meaning it takes up a lot of memory. So maybe this can slow down loading time of other components. Maybe some JavaScript functions are affecting the page's flow. So various things that we can notice there. And reliability. Again, you want to make sure that the page is available to everyone, that they can access it at any time, and that the page works flawlessly. So it's not something that when you log in or when you use it, you have to maybe even hope that you get a stable connection or a stable usage of the page. So you want to make sure that at any time your page is accessible and reliable to everyone. Now, let's go and dive a bit deeper into performance versus functional testing. So just to get an idea of how we use them both in combination. But before I continue, because I need to jog my memory a bit, does anyone remember what was functional testing, or what are some functional testing types maybe? You can write it in the live chat. So either what it is or maybe some functional testing types, if you remember them. We went through some of them in the previous lectures. So let's see. I see some people are writing. I see Bean wrote statement testing. Okay, it's a very interesting choice. Valentin wrote functional if it works as intended. All right. Let's see if somebody else wants to add. I see more people are writing in the chat. Checking that functions of an app or website work. Okay, wonderful, yes, thank you. Let's see if somebody else has anything to add. And Valentina is typing again. Let's see. So if clicking pay button, open the payment section. Wonderful. Yeah, that's a great example. Right. Yeah, so basically you get the gist of it. So basically functional tests are all that are connected to some kind of functionality of the page. So be that a component in isolation, an entire flow, maybe even code related tests like being also mentioned statement testing. I also see Susan wrote functional testing is a type of testing that verifies whether software functions correctly according to requirements. Wonderful. Yeah, perfect. So according to functionalities specified, to put it in a nutshell. And if you remember some other types aside from statement testing, we have unit testing, we have integration testing, we have end-to-end testing, we have so every type of testing you could think of aside from the ones that don't directly test some functionalities, those are all that we were looking for. So good job to everyone. I'm happy to see that you're already mastering more or less the materials that we've went through. So yeah, now we know and we just saw what was basically functional testing with this performance. So because the definition is quite straightforward, functional focuses on functional aspects and then performance it focuses on non-functional aspects. So as I mentioned a bit briefly before, the idea is you want to cover every aspect that you don't with functional tests. Speed, reliability, scalability, spike, data volume intake. So all those aspects you need to make sure that are working for the performance testing part, which is different for the functional test. You don't really concern yourself with those items there. Then you have to ensure that the system performs well under various conditions. This does not only apply under conditions where you have a lot of users. This could also apply when you limit the amount of memory, CPU, so hardware available for the server that you're running the page on. So it has a lot of aspects from that perspective. Where here you just verify the function of the software operates based on the requirement. So this is what Susan mentioned in the live chat. Finally, for performance testing, we simulate multiple users, transactions, and then evaluate how the system works under this load. So again, it could be a load of users, it could be a spike of users in a small amount of time, it could be a scale of users. So after a period of time, it increases for a given amount. So again, non-functional aspects is the key word that we should remember and take away from this bit. Whereas in functional testing, you already mentioned it in the chat, we check user interactions. We see if the connection between components are working as expected. So integration, unit testing, all of these fall in this category. So that is the idea behind it. Now, what is the importance of these performance tests? The first one is obviously user satisfaction. So when we are working as QAs, we should always remember that what we are aiming to do, aside from filling out the client's requirements, of course, is to make sure that users are satisfied. So whenever you get requirements, whenever you get a meeting where you have to discuss maybe what should be modified or changed, always think from the aspect of a user. So you are a user. What would you like to see in the application? The same goes for performance testing. If you're a user, you would be annoyed if you have very low response time. You would be annoyed if there is a, let's say, big concert coming up at Ticketmaster. You try to go to the page, you can't because there may be 300,000 users, so you can't access it, you can't buy it. So immediately that satisfaction goes out to play. So this is something to always take with you whenever you are working on projects as a QA. Performance or functional testing, this is a must. Cost efficiency. So If you can perform performance testing as early as possible, you save on cost because these issues are obviously resolved in an earlier stage of the development lifecycle. Then you have capacity planning. So once you have an idea of what the requirements are for the system to handle, you will obviously get input from the performance testing analysis into the capacity planning, so you will know what you should be working with. Although sometimes it can end up being the opposite or whatever the client gives you. But again, this is one of the things that are supported by performance testing. Then we have risk mitigation. Obviously, if you manage to catch all of the performance-related issues early on, you will be able to mitigate as much risk as possible, because when you reach the final stages of production, you can be very certain that whatever you caught won't happen, not only because you were testing and trying to focus on finding every issue possible maybe, but also because as you go into different environments, you usually get better outcomes. So if you catch the issues in weaker environments with the expected load, and even when you get on a better one, it should be a very, very low risk of any issues popping up. Finally, compliance. So you want to make sure performance standards and requirements set by stakeholders are met. This goes hand in hand for both functional and non-functional testing. If you have requirements, if you have a certain threshold that you need to meet, this is what you're chasing. So this is the compliance. When you've hit that mark, you know that everything is good to go. So it's highly important to have performance tests. And one thing I really want to stress, and I want you to take away with you as well from this lecture, is always try to implement performance testing as early as possible. I know that in many projects, also from my personal experience, they're usually pushed near the end. And oftentimes the case is that you're going to do them only on production. But if you have the opportunity to speak up, to try to negotiate something, I highly recommend, if you have the opportunity, to push them as early as possible. If you have the option to move them to an earlier environment, so maybe not production, but try to run them on stage, go for it. If you have the option to run them on dev, if you have the option to run them every sprint, go for it. The earlier you start, the better it is for the result, for the quality, and for the overall, I would say, reliability of the team, because you will have a lot of coverage done beforehand. So when you get to production, you don't have to stress about whether something could fall, whether something could end up blowing up because performance was not done beforehand. So you do not get surprised if it's a release, let's say. Okay. Um, do we have any questions so far till now? Okay. I don't see any questions for this section, so I'm just going to move on to types of performance testing. Thank you for the heads up, Ines. That's great. So, as I mentioned, there are different types of performance tests. So, one thing that many people confuse is that performance testing, and as you can see right now on my screen, the first type that we're going to discuss is load testing. And yes, if you, in theory, if you try to compare the definitions of both of them, you can say, well, okay, this is the same thing, right? But it's not. So performance testing is a, let's say, a group of types of testing, so similar to functional and non-functional, and it has different types of performance testing. Load testing is one of them. We will see others in this section right now, but it's key to remember that it has its own types. And although it differs from project to project what you will need to test. So sometimes the clients might not want you to meddle a lot with their databases, so you're probably not going to be doing any volume testing. Maybe the clients don't want you to hit the page with a heavy load, so you could do load testing with smaller numbers, but if that is a negligible number, you might even not do that as well. But you should be aware of all these as your arsenal, as your tools, so that you can know whenever you can implement them, recommend them, and of course, perform them. So the first and most common type of performance testing is load testing. So load testing, as the name suggests, is a type of testing that checks how the system performs under unexpected user load. So meaning you have your application, and then you're just trying to see how many people can access the application at a given amount of time. That means if, let's say, you are working on Spotify and you have a big album release of a famous artist, let's say, for the sake of it right now, Ed Sheeran, he had an album released, you know that in those days there might be a bigger amount of people listening to Spotify because they want to hear the album. So you would probably discuss it with stakeholders. What is the expected or the percentage of people in comparison to the people visiting right now, add those numbers up and run them for a period of time. So that is the idea. You take the number of users you expect to be on the page and just try to see how the page performs with that load. Now, I would also mention here that load testing is probably one of the most common types of performance testing. I wouldn't say it's the most common type, but there is a circle of a few tests that you will most likely be doing on each project. And this is usually the one most required by clients to run because I would say if you do load testing, you do technically uh, do a pretty decent coverage performance-wise. So that said, you should not only rely on load testing, but it is definitely one of the most handy and the most common types of performance testing. Now, moving on, we have stress testing. And again, the best part about these types of testing is they are very intuitive, as you can see from the name. So whatever you read is the same as the definition. So this means that you want to try and test the system beyond its limit. So stress it, basically. So you want to try to hit the system with as much transactions as possible so that you can see what is the system's breaking point and how will it recover. Now let me give you an example. You have, let's say, a let's use Spotify once again. So let's say you know that the album release could possibly have 3 million listeners at a given time. Now, we said load is you take 3 million, you run for a brief period of time, and that's that. For stress testing, if you know, okay, the maximum, at the very maximum we can get is, let's say, 4 million, I'm going to try and hit the system with 4,500,000. And then you're going to try with 5 million. And then you're just trying to see at which point the system breaks because you're already over the limit and you want to see what breaks the system, and if it breaks, how much time does it take to recover? How does it recover? What is the process? What does it do in that meantime? So usually you will see applications have this sort of reload reset auto built-in mechanism. So you want to check that, how that behaves, how that functions. And one thing to remember here is when you're doing stress testing, you would usually have a indicator of when the page has been overstressed, let's say. So you don't want to basically break the page entirely and shut it off. I mean, if you do that would be good, but it could also mean that you're trying an unrealistic scenario sometimes. So what is the most common practice we also had on our projects? We had this threshold value, which was, I think, on the one project that I worked with around 250,000 users. And when you pass that, we have a percentage rate of saying, okay, this many tests failed, that means it's overstressed. So we never hit zero. So let's say 99.9% failed. We never tried to do that because at that point it was even hard for the system to recover because it was unrealistically high numbers. It was out of the scope that we were testing. So it was really unrealistic for our project. So we were trying to hit around 30% pass. When you have 70% fail, that means that it's overstressed. This is some kind of breaking point. So we know that it's realistic. But again, when you're doing stress testing, you don't want to destroy the system. Yes, you want to see where it breaks, but that doesn't mean it should crash entirely. So you will see it when you go on project that you will have these values that you work with. Moving on, we have endurance testing, or rather known as soak testing. Basically, what this tests is the stability and how the system performs after an extended period of time. So, in comparison to load and stress testing, this is more focused on time. So, It doesn't necessarily mean that you're going to hit the system with maybe 50,000 users. You could probably even use 300 users, 5,000. So again, depending on the requirements. And the goal is to see what happens with the system over time. These tests most commonly are run for a very long amount of time. So you're not going to do an endurance test for 2 hours. You might do it for 20 hours. You might even do it sometimes for 25. For example, we had a submitter component in my last project, a job submitter, and the idea for it was that it should be running 24/7. And now the problem with it was at first it would shut down and restart after 24 hours. So for those 5 minutes, you would have an issue with not being able to submit anything. And then the other issue that we encountered was when we tried to hit it with a certain load that was nowhere near the expected load that we were supposed to be sending. At certain periods of times, it would shut down just because it took in too much information in those 24 hours. So that's why it's important to do endurance testing. You want to see what happens with the system over that time. And you can also simulate data increasing, maybe decreasing, maybe hitting a threshold and continuing at that level, but then decreasing, increasing again. You can play around with those parameters. And the idea is to, again, make sure that the system works well over time. Because most common issues that can occur is something crashes due to leaked memory, due to CPU over usage of the server. So there might be functions that prompt the system to use a lot of CPU, and when the CPU is at 99.9% usage, you will see the 503 that I just showed you earlier, or 504, even worse, for the page. So endurance testing, again, one of the most common types of performance testing, I would say, especially on large scale products and projects. So this is a must on every large scale project, because again, those have a lot of components, a lot of database connections, a lot of maybe even cloud technologies, but all of those come into play, and making sure everything is durable is a must. So there is no avoiding this if you're working as a QA on a larger scale project. Before I move on, do we have any questions so far? Regarding these three types. We have 2 to 3 more, I think. So if you have any questions now, see, I see Inas, you said, can you explain memory leaks more, please? Yes, I can actually do it when we look at the key performance indicators, because we will have a bit of a information about the issues that can happen with the memory, with the CPU. And I think we can combine it there so I don't confuse you now and then jump into it later again. So if that's okay, we can do it in that section as well. Yeah, no worries. But thank you. That's a very good question. Okay, moving on to spike testing. So spike testing, I would say third probably most common performance testing technique. Uh, Basically, it tests how the system behaves when you have an extreme increase in the user load or the traffic load at a certain period of time. So this can be tested for from 30 seconds, 1 minute, 2 minute, 3 minute, 10-minute intervals, where you get an abnormal amount of users on the page, basically a spike. Um, Most commonly, this happens when there is a launch of a product, and the spike usually happens on the login pages. Let's say if you have a login system, you'll see a big spike on that and the home page, because let's say you have 7 pages that are distributed for that launch. People will just come and go to different pages, so you're not going to notice spikes there. But for example, on the homepage, because everybody will want to see the new product, you'll see a big spike. A lot of people will visit the homepage at a short amount of time. They've just seen your announcement that you're launching something. So they come here, they log in. So those 2 pages are usually the ones that are most hit. And from personal experience, I can also confirm this. The the pages that are like the base page, the home page, or a login page are the ones that are mostly tested for spikes. It might be different on different projects, I can't really say, but from what I've seen and what I've analyzed on our projects, that has most often been the case. And the thing to remember about spike testing is you don't want to overdo it. So what I mean by overdo, when you do spike testing, you should always remember that you're not really only focusing on checking a big amount of users in a given time period. You're actually focusing that in a small period of time. So if I'm doing spike testing, it does not make sense for me to do the spike for 10 minutes because you have to simulate and think like a user. If you're hitting a certain page at a short amount of time, you're probably not spending more than 10, 20, 30 seconds on that page. So the spike test will at most be long about a minute and a half, maybe let's say 2 minutes, but it's usually these time periods that you're going to see on pages. Maybe some specific software would require spike tests with bigger duration, but usually these are short and very data or rather user heavy. So, for example, 1 minute, 5,000 users, 2 minutes, 7 million. I'm just getting these numbers up, but you always want to keep them short and concise. And I can say that whenever you work on any project, you'll most likely not do a spike test, which is lengthier than a minute, minute and a half at most, because that is the idea behind it. Okay, now we go to volume testing. So this is related to data. So you want to make sure that the database and the system's capacity are also well, let's say, rounded in terms of performance, scalability, and reliability when there's a lot of incoming data. Now, why is it important? Well, um, everything that you have in an application that you send, that you perform any action, that is stored somewhere, right? So everything that we do is stored. If you log in, your credentials, your username has to be stored somewhere. That's not something that is erased. So in order for that to work properly, so let's say you're logging into Facebook and another, let's say, batch of 150,000 people are logging in at the same time, the databases that are handling that should be well equipped to handle all those requests. So that should happen. The scenario should be that all of us 150,000 people log in without any issue. We don't get any errors that there's not enough memory or something. So any type of error that we see is an issue. Is most likely connected to the database. So volume testing is, I would say, fairly important, but is more common on, again, large, largely distributed systems and those that are maybe not so cloud reliant. And why do I say not so cloud reliant? Well, on cloud, it's a bit different. So you're not very much testing those databases that often. Databases like DynamoDB, CosmoDB, because again, those are the cloud provider services. But if you're using a distributed system, let's say you're using an educational platform for primary schools, and that is provided as a desktop application to schools in the UK, let's say, all of those will have separate databases, so they'll be distributed. And that is a must. When you have those distributed databases, that application needs to be working perfectly with those databases because all the professors, students might be inputting data inside it. So maybe uh, at a certain period, everybody has exams. They need to upload their exams to the platform. And when that happens, those databases need to intake that data. And it can happen that some exams are exempted due to these database issues. And that's how you can remember why it is important for this volume testing. It's not very commonly practiced, I would say. From my personal experience, I have not done any volume testing because we have had no need for it on our projects. Again, I've not really worked with distributed systems, but it was a thing on my current projects about 10 years ago, I would say, when it was still used as an application. Now it is being moved to cloud, so we're still not doing any such testing. Then we move to scalability testing. Now, one of the best things about modern applications and systems is their ability to scale up or down depending on the conditions. So if you have high traffic, the system should scale up so that everything can be accommodated. And likewise, if the system notices that, okay, traffic is low, maybe even 2 to 3 users in an hour, it should scale down to accommodate them to reserve costs. So the scale down moment reduces costs and keeps everything smooth running for given the needs. And then scaling up supports larger user traffic at a given moment. And why do we need to test this? Well, we want to make sure that the system does not use up resources when it's not necessary. So if we have 10 users per hour, we won't really need to use, let's say, 32 gigs of RAM and an octa-core processor for that, right? So we don't need a lot of memory, we don't need a lot of CPU for that. We can just scale it down to maybe weaker version of the CPU to a weaker version of the RAM from the memory. So it can just scale down and be used as before. Oftentimes, this scalability can be done manually. So again, depends on project to project, but those that are changing based on the user traffic should be tested whether that happens correctly. So if the system is dynamic, if it changes the scale depending on the user data, and we notice that we sent 10,000 users and we sent 5 users and the scale is the same, well, that way we know there's an issue and something is not working as expected. Now, before I finish, do you have any questions regarding the types of performance testing? Seraphim provided a very neat explanation for the memory leak, so thank you for that, Seraphim. Okay, all right. Yeah, basically, if there are no questions for this section, I think we can do a little knowledge check then. I think the questions will help us also solidify the knowledge. So we're gonna go for these few right now. We have about 5 to 6 questions, so we're gonna go through each. You can answer in the live chat A to D or 1 to 4, however you wish to do it. So let's get to it. The first question is, what is the primary objective of load testing? To determine the system's breaking point, measure the system's performance under expected user load, evaluate the system performance over an extended period of time, or check how the system handles an increase in load. Let's see, what does everyone think for this? You can write the answers in the live chat. Okay, I already see Susan wrote B. Let's see what everyone else thinks about the answer. I see more or less the answers are all going for B. I'll just wait a few more seconds before we continue. Okay, let's check if the answer is indeed B. I'm going to select it. And we can see that it is B, in fact, and yes, that is correct. So as I mentioned earlier, it's a bit intuitive to know which type of performance testing the definition explains. Load testing, expected user load. We have something for stress testing, so on and so forth. So not to give out too much information about the other questions, but nevertheless, good job to everyone. Let's move to the next question. So, which type of performance testing is also known as soak testing? Stress testing, volume testing, endurance, or spike testing? Let's see. This was a tricky little question here, but all right, I see answers already coming in. For C, okay, let's wait a bit to see what the others will say. All right, I see everyone is in sync today with the answer. So first one for B, now for C. I'll give you a few more seconds if somebody else wants to chime in to the answer. All right, I see more answers coming in for C. All right, I see Ines already ahead of the back, so we'll see the question after it. All right, I'm gonna quickly check this one. So I'm gonna click on C and let's see if it indeed is correct. And it is. The correct answer is C. And yeah, endurance testing is soak testing because you see how much the system can take, so soak up over time. So very well done, everyone. I'm very happy that you are all getting the hang of it. Okay, next question. Which type of performance testing do you continuously increase the load until the system crashes? Load testing, stress testing, volume testing, or scalability testing? Okay, let's see if Inas was correct with the prediction. It should be D, but I see now answers coming in B. Inas also wrote B. All right. I'll wait a few more seconds to see if somebody else wants to add something to this. If not, I don't see anybody else putting forward anything, so I'm gonna just check if it's B. And yes, the correct answer is B. So the stress testing is basically what we try to basically break the system in a way so to see what it can hold up to, which threshold value it can hold up to, what is the limit. So again, very well done to everyone for this one. I think we have two more questions. So which type of testing is used to determine the system's ability to handle a large amount of data? Load testing, stress testing, volume testing, or spike testing? Okay, I see C. I see a GIF with C, which is very innovative. I'll wait a few more seconds so we can provide more answers. I'll wait because I see some people are writing in the chat. Again, I see C, a unison answer once again. To see that. All right. I'm gonna select C right now. Let's check if it's correct. And it is. So when we're targeting databases, volume testing, how much can the database handle, or the system rather, in terms of data upload and exchange. So very well done for everyone. Let's move on to the final question, which is what does scalability testing assess? The system's performance under expected user load, the system stability over an extended period, the system's ability to handle sudden spikes, and the system ability to scale up or down in response to changing load conditions. I see immediately answers for D. Very, very much confident answers, I would say. Pretty fast provided in the live chat. Keep them coming. I'll wait just for a second if somebody else might want to add to the answer. If not, I'm just going to select it. Let's see. And that is correct. Again, it's a very intuitive, I would say, definition, scalability testing, assessing the scale up or down of the system. So pretty much telling us all that we need to know on what we're looking for in this answer. So first, well done to everyone. I'm very happy to see you all getting the hang of it. So yeah, keep up the good work and let's move on to the next section. All right, the performance testing process. Now, we talked a bit about what is performance testing, and similar to other types of testing, it does have a pattern flow that it follows in order for it to be, let's say, complete. Now, uh, you might notice that the performance testing process is quite similar to the general testing process. And what I mean by that, if you remember in one of our lectures that we were discussing in the early stages, we're talking about the testing process. And there we had planning, design, requirement gathering, analysis. We had test execution. so far, so forth. And I see a question from Binu. I got a question. How's the number of users, like from 1,000 to 1 million users, will affect performance testing? That's a good question. Basically, an application has so it's running on some kind of service. You usually have some kind of server, and you usually have hardware right on the server, and it can handle specific amount of people due to everything it has on the page. So maybe you have a very heavy application with a lot of code, a lot of JavaScript, a lot of images, so on and so forth. You have very much a lot of connections to databases. So I'm not going to go too much into detail. And your page, let's say, or your application at a given period of time can handle about 50,000 users. So not all applications have the same threshold. And what you can do is, this is the most common trend. If you're using services, let's say from Amazon or from Azure, it depends on what provider you're using, you can scale it up, let's say manually. So at the moment you're using a special type of server. Let's say that server has a dual core processor. It has 16 gigs of RAM. It maybe has 512 gigs of memory, and you can change it to be higher. You can maybe add 1 TB of memory, you can add an octa-core processor, 32 gigs of RAM, and then immediately that will increase the amount of users you can handle. And then basically that's how you determine how much users you can actually play with. If it's not documented, or if you don't have any analytic tool, which most projects do, you usually find out how much you can handle on the page with stress testing. That is like your, let's say, uh, tool to find the average amount and the most amount of users you can find in a moment. But usually you find out how much the application can do through analytic tools. You can use Google Analytics, you can use Workspace Analytics in Azure. So depends on what you're using, but um, that's how you plan out how much you test with basically. And yeah, you can't really run a million users, let's say, on a page if it's capped at, let's say, 100,000. Hopefully that answers the question. All right, moving back to the process. Basically, as I mentioned, we have the similar flow. So you're going to see some of these things that we've already talked about in the previous lectures. The first bit is the requirements gathering and analysis. So similar to other testing, let's say this testing types, you want to make sure to understand what your aim is for the performance test. So you want to see what is the most important for the users. If you're using an e-commerce site, you're probably going to want a good response time, good throughput for special events, and a good resource utilization. So this was just what I was talking about before. So you want everything to be up and running. You want to have good overall properties for the servers you're running the application on, and you want everything to be smooth. And that's why you need to determine and discuss with clients and do analysis using these analytic tools to see what fits your application. Then you determine acceptable performance levels and benchmarks. And what does this performance levels and benchmark mean? You basically see what is your pass, let's say your passing grade. So if our application is going to have at most 100,000 users, let's say, you would probably say, okay, then for load testing, we should aim to make sure that 100,000 pass, even 105,000 to be around 90%, 95%. So you essentially map out what you find as a successful run in terms of the data that you've combined. And usually that process comes hand in hand. These things you usually again agree on with the clients. So this is something that the testing team plans out. So you would say, okay, we think that 80,000 users should be tested if we only require 70,000 for the page at a time. You present it to the clients and they might say, no, you just test with 70,000 and that's it. And then you say, okay, then that's that. So your part is to plan out and give your suggestion and then combine it with whatever the client will require and basically set what is the pass rate, what is the benchmark we're trying to reach. Finally, gather information about expected user load and usage patterns. Again, this is why you need those analytic tools. For example, if some of you've had experience with maybe Google Analytics, you might know that you can see how much time people spend on a page, what is the most frequently visited page. If there are some launches, you can see how many people were accessing a page during launch, so you can maybe map out what is the average duration of a person on that page, what is the average on that page during launch. There are a lot of things that come into play really here. The most important thing is to remember that you want to do a very thorough analysis so that you can get those numbers and present them to the client. So when you're doing performance testing, analytics is like your best friend. So you have to make the most of it. And I would say it's not something that's very difficult to master. It's just data. It takes maybe, I would say, about an hour or two to get around because those tools are usually filled with a lot of data. But once you see what you need, it becomes very, very simple to navigate through. All right, then we have the test planning and design. Now, once you got all the data covered, you have already discussed everything with your customer, your client, you come to the planning and design. So you want to make sure that you have a very detailed, very comprehensive test plan where you say what you're going to do, or rather the test strategy and what is the scope. So you want to say what are the testing goals and objectives. Again, whether you're going to be running spike tests, volume testing, when you're going to do stress testing. Again, it differs from project to project. So you want to define what is the goal and objective. So you want to say, okay, we want to see how the system performs in short spans of time when we add about 50,000 users in that period. Then you identify types of performance tests to be conducted. Again, you don't usually do all of the performance tests. You need to discuss again with the clients and also see yourself what makes the most sense. Again, if you are using an application with distributed databases, you'll probably want to do volume testing, even load testing. But if you're not, if you don't really have the need for that, if everything is in the cloud, if you're not really connected with those database services, then you don't really need to test that. It's not in your scope, it's not in your domain, so you will probably leave it out. So planning what tests to run is essential. Then you need to select which tools and frameworks you're going to be using. So again, every amount of uh, every performance testing tool should be chosen based on what the project needs. If you want fast and reliable load testing for not so big, for not a big traffic simulation, you can use JMeter, for example. If you want something even more efficient, better with reporting, you would probably want to aim for something like Gatling K6. So we will talk about the tools a bit later in detail, but you need to make sure that you know which tool fits your project needs. Finally, design test scenarios and use cases based on real world usage. Test cases. So functional testing requires them. Non-functional testing also requires them. They can be omitted in some scenarios, and you can just use the report for clarity, so what you are running. But if you have the test cases, it's easier for you to follow for what scenarios you need to do. It's easier for the customer to understand what you're trying to run and why you're trying to do it. And it's very helpful if you remember for traceability. So when you come back sometimes to the same page that you might need to retest again, you will immediately know which scenarios you ran. You don't need to use up time on trying to plan them out. So you have something written down what you can follow in the future as well. Now, after you've done the nitty gritty, we call it in the QA because analysis and test case design is probably one of the most challenging phases. The other one is the fun part, is the test environment setup. So you want to basically enable an environment that mimics production. As I said in the beginning of the class, there are some projects that will require you to do the load testing on production. That is one case that we had when I was doing the performance testing on my first project. So we had to wait until everything is set up on production. So all the code is pushed and merged there. And then they would have a silent launch for 1 week. So nobody knows that everything is on production. And then we had the early mornings on our end for those 3 to 4 days before the end of the week to do our load testing. which I don't recommend. It's if you crash the page and it's crashed for the entirety of the day, it's hard for developers to work. It's hard for the clients to do their testing. It's hard for users to access other features of the page, maybe. So a lot of things can happen from that. So having an environment that mimics production where you can safely do performance tests, it's an absolute go. So if you have this opportunity, I highly recommend it. Then you need to set up hardware, software, whatever you need for testing. You need to configure network servers to match the prod environment. This can most often be done also by the dev team. We've done it both on our end. We've done it together with them. They've done it sometimes for us. So this is changeable. And then you need to make sure that you have the correct tooling available there. So that's something to remember. If you have, let's say, written tests locally in JMeter, if you want to run them, in your environment, you need to install it there as well because it is dependent. So you can't run the tests without having the tool there as well. So um, that is one thing to keep in mind. And then you prep the data. Basically, you want to make sure everything is as similar as possible to the real deal. So you want to use realistic data. Basically, you don't want to just, let's say, use a single user and then iterate that single user 10,000 times. That probably won't be realistic. So you want to make sure everything is accurate. You want to make sure that you anonymize sensitive information. This goes for the same for coding, so you don't want it to be out there. So I highly recommend when you prepare these environments and scripts, you want to um, encapsulate everything in variables or pull them from a document that you have so it can't be seen on the net. You want to make sure everything is up to date and validate that the data aligns with the expected input and output. So validate whatever you will be using just to make sure it's on the right track. Then move to the test script creation, and I would say this is probably one of the most fun parts. So you design and develop the scripts that you want to simulate the interactions, and this differs from tool to tool. So if you're using something like Gatling, let's say you're going to be writing scripts in code. So uh, Gatling writes Java-based code for performance scripts. And also another term for scripts is what we will be doing next Tuesday in hands-on performance testing, which is with JMeter, where they don't look like scripts, the setup that you do in JMeter, but essentially those are load testing scripts, except instead of writing them in code, you have a GUI, a very wonderful GUI, where you fill out what you need to fill out, and then that runs everything for you. And once you've created them, you've parameterized them, so you hide the data that you need to hide, you validate that everything is working, you are ready for the execution. But before you move to the execution, there is a very important part. You should always test if your scripts work. And you don't need to test the scripts by using 50,000 users. You don't have to do that. We will see in the next lecture as well for this, but usually you put 2 to 3 users, you run one loop of the program just to make sure that everything is working as expected so that there are no issues with the scripts. Now we have validated, we have prepared our scripts. It's time for execution. And this is a very important part of performance testing. And why is that? In contrast to the, let's say, automation execution and the manual execution, um, this requires a lot of monitoring. So yes, you will run them in different scenarios, but it's very important that you're present to monitor the metrics as the scripts are running. And why is that? It could be even a slightest second where you can notice a big spike, a big issue within the application happen when you're running the scripts. So it's not only that you run them and then you open the logs and you see what happened, but you need to be there in real time. There could be specific scenarios that happen at a given time interval. You want to note that down. You want to see what happened exactly instead of losing time later on to try and find through the logs what is happening with the performance tests. And I'm saying this because when you run these scripts, especially for more than 10, 20 minutes, you will see a lot of logs and it becomes very difficult to see where the issues occurred if you're not following them in real time. So the monitoring is very, very important. Then you basically execute based on the scripts. So if you need to run a spike, you will probably do less time, more users. If you need endurance, you'll do more time with a given amount of users. You're going to check, as you mentioned, the logs, the data in real time, and essentially follow everything as it happens. Now onto the monitoring and analysis. This ties into the execution. So the monitoring happens during and even after the execution along with analysis. So what do I mean by that? Again, it's very hard to just open logs from a performance test and try to read through them. You want to follow them in real time. You want to write down everything that's happening, and you want to basically see what is happening with the system and analyze it. So you want to compare it maybe with the Google Analytics, whether it says there that there were that many people on the page, it was performing like this. You see, aha, so when I was testing it, it also performed similar to what Google Analytics tells me, or whatever analytics tool we're using. I can see that it's stable. I can see that more than 99.9% of users are able to use the page. So you want to basically note that, see some patterns, see how some pages differ in their performance based on the load. A lot of parameters just to intake, and then everything needs to be neatly analyzed and added into a total summary. Now, once we're done with all that, we have the reporting. Now, the best thing about performance testing is that almost all of the tools have a report generator in HTML, which is great. It's very easy to understand. However, I don't recommend you only use that as a test evidence when you're done with performance testing. So basically, the reporting part is taking out everything that you got as a result from the monitoring analysis and from the generated report, and then writing down a detailed report summarizing what are your findings, what happened in which interval, what are some issues, and very important, what are your recommendations. So when you do this performance testing, there's also this phase which is known as recommendation providing, which you basically say, okay, we noticed that the page under these, let's say, hardware circumstances performed like this. When we increased the capacity, it performed like this. So our recommendation is, if you expect, for example, that many users, go with this capacity. If not, you can scale it down to this capacity. So you want to give suggestions as a QA to what is your approach to the overall application performance wise. So that's why it's very important to monitor, analyze, note down, draft a very in-depth report, and provide as well your expertise based on the performance tests that were executed. So the reporting hand in hand with your suggestion as a QA is very much valued, especially in performance testing, where most of the time the stakeholders and clients will not be as tech savvy with this bit as you might be with the developers. So giving them a suggestion very much supports your, let's say, test evidence and gives them confidence in what they're going to do with the system moving on. Okay, that was a bit more talking from mine. So I want to see, do you have any questions regarding the performance testing process? It's quite similar to the other processes, but again, it's the first time seeing it. So if you have any questions, feel free to write them down in the live chat. Okay. Well, if not, I think that'll be it for this session. So I think we can go with the break. Thank you, Jumana. All right, everyone. Let's go back to the content for today. Okay, so we went a bit through the performance testing process, and a couple of times throughout the lecture, you might have noticed we were referencing this key performance indicators term a lot. Now, what are KPIs or key performance indicators? They're basically metrics that we use to make sure that the performance of an application is either underperforming or performing as expected. Now, we as testers usually need to basically make the most of them, because these are used in our reports. These are used for us to test and make sure that everything is working as expected. And also, there are also points of where we can make our suggestions moving on. So maybe we would think that something is too slow. Maybe we think the response time could be actually enhanced based on what we got from the results. So that's why these are the bread and butter of what we need when we're doing performance testing. Now, the first KPI and the most common KPI you will come across is the response time. So what is the response time? This is the amount of time that the system needs to respond to some kind of user request. Meaning, if you click on a button, the response time is how fast the button performs the action. So if you click on submit, how fast will you submit the form? Or how fast will you get an answer that you have submitted the form? So it starts from the moment you send the request, you click the button, that goes to the server gives a response, and an action is taken. So all of that time is known as response time. And the faster it is, the better, of course. But there is a thing to keep in mind. Not all elements of a page have the same response time, and not all are expected to behave at the same speed, because it's not only the factor of response and request that play a part into how fast this response time is. It also comes to other components. It could be some functions that are also added in relation to some kind of connection to that component and another. So this is also usually discussed with clients, and you will have what is an acceptable response time and what is not. So again, it's not always important that it's the fastest response time, but rather it should fit our scope. Now, um, uh, the other thing that I wanted to also mention regarding response time is that when testing this, uh, the focus that we have for the response time should also be taken from a user's perspective. So let's say you're testing a payment form, because we started with the example. You should also take it with a grain of salt when you have some specific scopes, if they are realistically applicable to users. So if you, let's say, submit the form and then need 5 times to receive a confirmation email, you might say, okay, that is fine. You know, some services usually do that. But let's say you receive the mail after 10 minutes, or you receive the confirmation on the page after 10 minutes. Again, it takes a lot to process the request, but the user should still be served in a faster time. So you can always come up with your own proposal. You can maybe try to see with the development team what can be enhanced, what can be improved, so you can reduce that response time. So always make sure to keep in mind that you can actually rely on the part of a user. Try to see if this is something that will satisfy your needs when you're visiting a page. If it is, if you think that is right, it's fine. But it could be sometimes the case that does not make sense from a user standpoint. So in those scenarios, it is important that we put up our voice and mention or suggest some enhancements that we might think of. Next up is throughput. And throughput, simply put, is basically the amount of requests or transactions, however you want to call them, that the system can process an amount of time. So usually measured in seconds, or rather requests per second. So how many requests can the system process, basically? So how many login clicks can the system process? So let's say we are 10,000 users. We're trying to log in all into the same application, all 10,000 of us. If everything goes smooth, then the throughput, definitely the system can take up all of those requests in that small amount of time. Because obviously we will not all be logging in at the exact same time. So let's say the user can take up 10,000 transactions in 5 seconds. So that is throughput. So how many transactions in a given amount of time can the system handle? And throughput is basically seen in all performance testing because it is a very important indicator. And why it is a very important indicator? Because it will tell us how much actual interactions can the system handle. And an interaction is not only your entire flow, let's say, of the form population. An interaction is simply visiting the page and clicking anywhere. If you click or scroll and try to hover over an image, that's an interaction. That sends some kind of request. So anything that you perform that affects the page is actually sent in. So it's very important to see the throughput and see how it can be handled, because if people visit, let's say, the homepage, 50,000 people, which is very likely to happen, you'll have a lot of throughput. You'll have a lot of throughput, especially when the people will try to search a term, click on an image, hover or anything. You're going to see all of this information flowing through. And a good thing to note for throughput is you don't really need to uh, dwell too much on it. So you will see large numbers, a large number of transactions that are happening. And if everything is okay, you don't need to stress too much about it. And this is usually also very easily detected in performance tests, and we will see just that in the hands-on performance testing lecture. Then we have resource utilization. So um, as I mentioned before, a big part that plays in how an application performs is its CPU, its memory, disk, network, so on and so forth. So these are resources available for that application. And it's very important to see how they are utilized while we are testing the application. And yes, you do actually get results after you finish testing the application, after we finish running our test scripts. But it's a very good practice, and I very much recommend this in all teams that have worked with performance testing. We have practiced just looking at real-time progress of all these resources. You can do that. You can do it in the task manager. You can use third-party tools like Azure Monitor if you want. So depends on what you're using on the project. And what happens here for resource utilization is you basically see how does the application uh, work with the load, or rather how the resources support it. It could be a case when you're stress testing, especially, that you will see that the usage of the CPU is 99.9%, not 0.9, but 99%, which is bad. It should not be 99% usage, because if it's 99%, most often you're going to see 503 gateway timeouts. Also, you can look at the memory. The memory can be overused. So this refers back to Binu's question from the earlier session that we had. There could be memory leaks, and you can actually catch them early on if you're monitoring quite frequently. And what the memory leak means is that a resource is not releasing its memory. So imagine you have a backpack and you're putting in books, right? So every day you go to school, you have your books, and then the other day, instead of removing the ones that you don't need, you add more books. And the other day again. Eventually, your backpack is going to tear, right? You're going to have too much books. You're not removing anything. You're just adding stuff inside the backpack. And that's a memory leak. So the resource takes up too much information. And then what happens is the application blows up. It crashes. So that can also happen if you're monitoring, if you're looking at the resources, you could catch on to these things. Same goes for the network. So you can see if there are some oscillations in the network, if it's responding quickly enough, if the bits are flowing at an acceptable rate. So all of these things, again, you use different and various tools to notice this. This is not just something you click and open and see in the application, but it's very important to make sure that you are monitoring all of these and that they are utilized properly. So anytime you see, I would say this is a rule of thumb, that a resource is at its maximum capacity, then there's definitely something wrong. If it is within minimal to mid-range, that usually means that everything is stable. But once you see this extreme number or fairly above 70% and you're just running standard performance tests, that means resources are experiencing some issues and need to be checked. Concurrent users. Now, when we will be doing the hands-on testing, you will see concurrent users quite frequently. And you will also see them with many of these performance testing tools. So how does the concurrent users work? You basically simulate users interacting with the page in parallel. So that is the idea behind it. Is that as this graphic you can see here, everybody's accessing the server at the same time. And the tools are usually based with that amount. You usually don't say number of users, you usually say number of concurrent users. So whatever you're writing in those programs, you're writing it so that the users are using it in parallel, or rather the simulated users. And if you want to understand, let's say you want to just see 10,000 users an hour, so you don't need all of them to be concurrent, you can also modify this, because again, this is all done by using concurrent users, and that puts a lot more stress in the system from the start, and that's why it is done so in these tools. But it's a very important parameter, and you will see when we do the exercises, I'm going to show you some tricks on how to calculate how many users you're going to need, because 800 concurrent users does not mean 800 users per hour. It requires a bit of math. It's simple, nothing to be scared. But yeah, it's a very important indicator because we needed to calculate how many users an hour, a minute, 30 minutes, or in general we need to use, and essentially to know how our application can handle those at the same time. So it's a very important parameter and one that you will be seeing very frequently once you also start to do these performance tests. So keep it in mind. We will talk more detail about it in the later lesson. Do we have any questions regarding the KPIs? Again, I know it's a bit more information to take in, but I promise once we practice a bit, it all becomes a bit more clear. Okay, if there are no questions, I want us to do one more knowledge check from the content. So I'm going to move to that. All right, so here it's a bit different. You don't need to write the A, B, C, D, or 1, 2, 3, 4 answers. We'll just have a drop down from the questions here, and you can just tell me which option do you believe is the correct one. So, question 1. The initial phase of performance testing focused on understanding the objectives and criteria is known as. You can write whichever you think is correct in the chat. Let's see what you all think. I see requirement gathering. All right. I'll give it a bit more time so the others can look from the answers and see what they think is correct. I see another vote for requirement gathering. All right. Okay, I don't see anybody else adding any answers, so I'm just gonna select it, and you are correct. It is requirement gathering. So this is, as I mentioned, similar to the other testing phase, testing process rather. In functional testing, you need to get the requirements, analyze them, note down anything that you might need before you continue with designing and executing tests. So well done for this one. Let's move to question 2. During the blank stage, a detailed outline of the testing activities, including strategies and scope, is created. So which stage do we have a detailed outline of the testing activities, including strategies and scope? I see 2 votes for test planning and design. Okay, that was quick. Let's see what the others think. Maybe there are some different answers. Give it a bit more time. I see some people are writing in the chat. I see another answer for test planning and design. Wonderful. It's very great to see you're all in sync today. So that shows that you're following and are very much engaged into this. So good job. Okay, I'm gonna select it. I see more people are writing, so I'm just gonna add it and see if there's something different. And you are correct. for the test planning and design. It is the phase where we outline activities and we add what is in the scope, strategies, test cases, so on and so forth. So this is basically that bit. All right, number 3, the phase where a controlled setting that simulates production conditions is configured is the which setup? Monitoring, test environment, execution, reporting. All right, I also see 4 rapid answers for test environment setup. Okay. See, other people are also writing in the chat. Let's see if they have any different responses. All right, fairly straightforward. All of you are in unison for test environment, and you are right again. It is the test environment. So when we simulate something similar to production, it's just an environment setup. 2 more questions to go. The total duration for a system to handle a user's action is called what time? So what is the time? I see again, unison answers for response time in the chat. I'll wait a bit to see if somebody else maybe has another take on this. Going once, going twice. All right, I'm going to select response, and you are correct. So response time, duration for how much time a request is handled. So again, very well done for that one. And we have the last question, which is number 5, and it says blank is the number of transactions or requests processed by the system in a given period of time. All right, I already see output. I didn't even need to reveal the answer. That's very good. I'm happy that you're all very much engaged in following this, so keep up the good work. I'll wait a bit so that maybe others want to, well, maybe others think it's a different answer than output. Again, there's no incorrect approach. We're here to learn, so you can safely say if you think it's otherwise. All right. I'm just going to select throughput, and that is correct. It is the throughput, the number of transactions that are processed by the system in a given period of time. So very well done, everyone. You've been crushing it today with the knowledge checks. So happy to see that, and hopefully we'll do that on the Kahoot as well. So let's go to the tools and best practices for performance testing. Now, I mentioned in the lecture that you will be using specific tools for performance testing. And here there are a few listed. We'll talk a bit about them. I'll give you some information, and then we'll also see when and why to use them. The first, the most beginner friendly, and I would not say the most common, but a fairly common tool for performance testing is Apache JMeter. It's open source. Its main and only purpose is performance testing. So you don't use it for anything else, basically. It is basically a GUI. It's very intuitive. It is something that we will learn in the hands-on performance testing lecture. So we will have the opportunity to work with JMeter. It has a very good support for many protocols. It does have a lot of functionalities, and when I say a lot of functionalities, I mean a vast amount of functionality. So you can really simulate the behavior of users that are hitting the page in very, very detail. And I'm talking, for example, simulating a user going to the page, staying for a brief amount of time, navigating to another one, coming back to that one, approaching a different page due to something else. You can simulate this behavior with the GUI very efficiently. You have a ton of commands, you have plugins that you can add into it. So it's a very neat tool. If you want to master it, it takes a bit more time. But if you want to get into performance testing, learn the basics, and even apply the basics of performance testing to some projects to a certain degree, it's definitely the best tool out there. So it might not be the one with the most code, I would say. But again, it's a very useful, very beginner-friendly, and widely used performance testing tool, which I highly recommend. And we will see in the hands-on lecture. And I would also add for the use case, it is good for heavy loads on a server network, or basically analyze the load performance of a page. for larger applications, we'll go into detail for another tool. Second, we have load runner. And basically, this is, I would say, uh, something similar to JMeter, but not as widely used. Again, it supports a big range of protocols. It is good for distributed load testing, so it can simulate a lot of users for distributed databases even. Gives good reporting and analysis. Again, quite similar to JMeter, and it can be integrated into CI/CD pipelines, which is a very big plus. And it's basically good if you want a lot of protocol support and advanced testing for complex applications. So it does the same things that JMeter does, but it's a bit, I would say, a level above it than JMeter because you can handle more complex applications with it. I've personally not used this testing tool so far. We have not had the need for it, but it is used in some teams at the company that I work for. So I know that it has some better capabilities than JMeter, but it's a bit more, let's say, challenging than.
I believe Angelo has disconnected. I'm personally also having internet issues. So let us wait a bit. He's back. Yes,
Okay.
perfect.
Yeah.
Go ahead.
Yeah.
All's good.
Can you? Oh, all right.
We
Yeah.
lost you for a while, so if you can just repeat the last minute or so, that would be great.
Yeah. Okay. Sorry about that. My router seems to be working, but it looks like the net was done. Yeah. Basically, it was a wrap up for load runner. As I mentioned, it does the similar things to JMeter, with the exception that it is used mostly for more complex applications. So maybe somewhere where you can't really fit in JMeter, maybe for distributed systems, it can definitely be useful. However, again, I would, for similar applications of low complexity, always choose JMeter. And then we go to Gatling, which I personally think is the future of performance testing. Again, it's open source and it is super high in performance. So Gatling is code-based. So I would say this is a lot more advanced than both Load Runner and JMeter. And what is done, this is basically written in Java. So you write the scripts in code. It's not with a GUI where you get to set up everything similar to the other two. And this one is currently, I would say, the one used on most large-scale projects. For example, we were using this tool for joint cooperation with ARM and Microsoft. So we need to test a very large amount of jobs that were going in. We're talking about 500,000 of jobs. And if I convert that to virtual CPUs, it's double or triple that amount in some cases. So we were using Gatling, and it's very efficient. It can handle the load. It can handle larger loads than that. You can also do a bit more reading on it. I think Netflix also makes use of it. So it's very high performance. It's used for absurd number of users that you need to simulate, or for transactions that you need to simulate. And again, it's best suited for very complex applications. Again, this is a bit more advanced. I wouldn't really recommend jumping into it directly. So the more natural flow is JMeter. You learn a bit about performance testing using it. And then after you get comfortable with that, you can change up maybe to this tool, because again, this will be mostly implemented on projects, I believe, at least in the next 5 to 6 years, maybe. Now, regarding what is the criteria and which tool you want to use, there are several. One is protocol support. So you want to make sure that whatever you're testing with basically supports the protocols that your app uses. So HTTP, HTTPS, FTP, file transfer protocol. So it depends from application to application. And if it doesn't support some of these, then you're not going to need it basically, because you cannot use it for your software. Nowadays, most tools support the basic protocols, I would say. So if you're looking for HTTP, HTTPS, FTP, JDBC, whatever protocol you can think of, basically the standard ones, usually all of them provide support. But again, it's not bad to double check if, for let's say, you're given the task to do the performance test, just skimming through the documentation, you will immediately find what you need for all of these tools. They're very detailed. They provide information on what they support, but you'll find that you will basically have support for these protocols in most. Then it's ease of use. So if you're feeling comfortable that you want to write code, if you want to be doing the tests at a, let's say, more advanced level, when your project requires, let's say, medium to low complexity testing, you can absolutely go for something like Gatling or K6, but you need to make sure that it is comfortable for you to use, it is comfortable for the project, so it is not something that basically weighs a lot on the entire process. So most of the time, if you're looking for ease of use, if your project supports it, you go with tools like JMeter and LoadRunner. And if not, if you want to test larger scales, then you probably have to go with some of the more advanced tools like Gatling. But this bit again, it depends on the project, depends on the client requirements as well, and you as an individual, how comfortable you feel at that moment with those tools. Then we have scalability. So you want to make sure that your tool fits the needs based on scalability. So if you want to test from 5,000 to 15,000 to maybe 30,000 concurrent users, you can make use of JMeter. If you want to go 10 times the amount of what you can do there, then you will probably need to change to another tool. Again, this is all verified in those documentations that I mentioned. So whenever you have the opportunity to choose from, you will probably read it from there. Then we move to reporting and analysis. So you want the tool to provide reporting and analysis options, basically give you some details in the reports that it provides so that you can construct your own detailed reports and also have the ability to get insights on the results. So again, you're not only monitoring during execution, you also need to read and compare after everything is done. The good thing is most tools provide both reporting and in-depth result, let's say, description in their outputs. So this is nowadays basically, this is a, let's say, packed in with any tool that you will get. Then we go integration with CI/CD. This depends on the project. So some would like to integrate your performance tests so they run automatically. So you can see which tool fits best with your integration policy. If the project is Java based, you can use JMeter. You can also use Gatling. Both are good options. If it does not depend on the language, you can maybe use any tool that you can find that fits it. So again, this all depends on the project. And we finally move to cost and community and support. Costs, again, you don't want to use a tool which will be a heavy cost on the project. And the good thing here is most are open source. So more often than not, you're going to be using either JMeter, either LoadRunner, either Gatling. So all of them are open source. You can use them for free at larger scales as well. But if the project, let's say, uses something like an Azure supported tool for which you need to probably pay some kind of fee when you're using it, depending on the resources you use, then you will probably have to go for that one. And then community and support, you want to have a good community from the tool that you're using because sometimes you might get stuck with some tests, and the best way to find out about some issues that have been resolved in the past is to look through those forums. So having a good community and support is helpful. As with this, same goes for automation testing, but I wouldn't say key because, again, you can find the support just by looking through some of the documentation, which is again updated by the community, but sometimes also by people directly working with the tool. So it is important, but there are higher priorities than this. So again, always take it with a grain of salt which tool to use, and always aim for your project needs, unless you're told to which you have to use by the stakeholders themselves, in which case you will have to work with that. Most often when you go to projects, they usually have some kind of flow with their performance tests and they have a determined tool. So you will most often not need to do this decision at the beginning, but moving onward, when you get into more, let's say, lead roles, you will have to take all of these into account. Do you have any questions so far regarding the tools or how to choose the tools? Okay. I don't see any questions, so I'm going to move to the best practices for performance testing. Now, I think we covered a wide spread information about performance testing, and the last bit related to that is what I want to add, the best practices. So remember that we were talking about shift left testing. Does anybody remember what was the idea of shift left testing? What does it mean? You can write it in the live chat. So shift left. I see being wrote early as possible. Wonderful. Yeah. See, Ines is also typing. To start as early as possible in the software testing lifecycle. Wonderful. Yeah, that is correct. So we want to, when possible, start testing as early as possible. This is one of the best practices for performance testing as well. So yes, you will get the situation where you test on production. It's quite common, but you have the opportunity to implement it, do it as early as possible. And why do I say that? Well, it imagine you have your own performance testing environment, everything is deployed, you've tested the functionalities there, you run the performance test, and you immediately see every issue possible regarding the performance. You can fix it, rerun the test, see that it's all good, and when it goes to production, that's bound to have little to no issues just from getting it as soon as possible. So trying to run this performance test earlier than just waiting for the release date, it's key. And even implementing them in a CI/CD where for every bigger release, you run these tests again, it's a definite bonus. So if you could do that and have that pipeline running for every release or for every deployment, it will just make sure that with every change that you do to the code, for every change that you do to the page or the software, that the performance will still be stable. So as early as possible, similar to other types of testing. Now, the other thing I really want to to stress here is this is one of the two things basically, realistic scenarios. So when you are doing performance tests, it's very easy to get derailed and then to absolutely destroy the software with abnormal amounts of users. We have done this a few times. This was a client requirement, but we still did it. It's very important to let everyone know and to inform yourself about what is a real world condition. Because if your page can realistically take up 80,000 people at most, right, then it makes no sense for you to test at that given period of time if the page can handle 130,000. It is going to crash. It is not going to be able to handle 50,000 more users. You can also try with 500,000. Again, you will crash the page. What is the drawback? If you have a separate environment, you can crash the environment and then it can become a real hassle to just recreate it, restore it, restart it. It can maybe take up more time to boot due to some components being broken because we ran an unrealistic scenario. So running unrealistic scenarios can crash the application when it's not necessary to do so. And the other drawback is sometimes you might actually underperform with your performance test. So you can actually have less than expected users. And if you have that scenario, well, the page can have issues on production, which is the worst case scenario, right? The users can interact with it and see there are some issues. So avoiding any under, let's say, under the threshold value amounts or way above the threshold value amounts of users is the perfect, let's say, hotspot. So use realistic data, use realistic amounts, and I would also add incremental load conditions. So when you're testing, you can try to increase size to size from one load to another and then reach up the amount that you need to. It's ideal to go a bit above the load that you're expecting, but not so much that you will destroy the entire application. So there are some things in the testing world where you live with some facts, and that is if you can handle 80,000 and the client say we will only do 80,000, you don't try to do 200,000. So you just kind of try to be in the realistic zone. The other thing, as I mentioned, highly important is monitoring. So when the tests are executed, you need to monitor constantly. Of course, when you're doing these endurance runs of 24 hours, you're not expected to always look at the tests 24/7. But for most tests, like load testing, spike testing, especially volume testing as well, you want to be there and want to see what is happening throughout those tests. So you want to have, usually you will have a setup of a monitor and a laptop. In one window, you're looking through the logs all the time. So what is happening with, is there an error? Is there something happening with the content? And in the other, you will have a task manager or some performance testing tool that tells you what is the situation of the disks, the memory usage, the CPU, again, depending on how you run them. And the best way to do so is to have monitoring tools. There's a handful displayed here, like Grafana, Azure Monitor, Prometheus, Nagios, Datadog. Most used ones are Grafana and Azure Monitor if you have AWS or Azure setup. They're very comprehensive, give you a lot of information, and are, in my personal experience, the best probably because the data is very well structured and easy to understand. But if you do not have those, again, you can look through the logs that you have from, let's say, JMeter. You can also use run the test directly from your server instance and look at the CPU usage and memory there in Task Manager. Again, this is a bit more primitive maybe and a bit more low level, but it does the job. You get information, and it's important to be in the picture while we execute the test and as well after to make sure that the results line up. So monitoring is very important for performance testing. Finally, identifying and addressing bottlenecks. So you want to make sure when you find these issues, try to see what is the root cause. It is the same with functional testing. The difference here being that we're actually trying to see what is the root cause performance-wise. So you want to look at the results. Maybe you will notice that there was an item that was taking too much memory. Maybe you will notice that some specific component took too much to respond. So they clicked on the button responded after 10 minutes. Maybe you will notice that the search is taking way too long. So maybe you see that the output is not correct, response time. They're usually very easily indicated. You will see a lot of red signs or errors. So that's how you immediately know where the root cause is. And after you have done so, you want to address this issue, optimize, apply the changes, run the tests again, make sure that everything is working as expected. And in this case, you will really need collaboration with the development team because, again, as testers, we don't have too much insights into the networking bit, into the let's say, interconnection of components. So just trying to find at least what is the root cause that we can. Providing it to them will help the developers find a solution, add it as soon as possible, optimize the application in a way, and then allow us to rerun the tests, have less issues, and just cover everything in the meantime. So highly important to also try to address root causes in non-functional tests because, again, it's a type of testing, and the more detail and the bigger lead we can give to the issue, the better for both us and developers, and time-wise for finding a solution to the issue. Do you have any questions for the best practices? Okay. If not, I think because we have a bit of more practical things to do in the next session, I think we can have the break now and be back with you in about 10 minutes. Jumana, you can take over.
Thank you so much. Enjoy your break, everyone.
Right. Let's continue where we left off, everyone. I think you can see my screen right now. All right, so we're near the end of today's lecture. We'll have a little lab before we finish and a bit of a walkthrough for um, some Chrome Dev tools to analyze some performance metrics. So similar to when we were looking through the dev tools for our locators and constructing our XPaths and CSS locators, when you do performance testing, there is an option to look at some parameters when you're using the dev tools. Now, it's important to note here that although these things are very useful, you are not going to be using them during your tests. So you can use them to check if something is wrong with the page, if there are some issues and you think they might be performance related. So you can absolutely open up and see if something does not make sense. But when you're actually executing the tests, you're going to be, as we mentioned before, looking through the monitoring tools that you have, like Grafana, maybe inside your JMeter logs as well. So it all depends on that. But for the time being, we will take a look into some options that you can look at using the developer tools on some pages if you want to practice or even to see what is happening. So I'm going to close first my tools that I had opened. So the way that you access them, it is the same as before. So you just right click on the page and then you go inspect. And now we up until this point, we've only used the elements section and the console. So these were the ones that we only used. Now the ones that you can use for performance testing and just for general non-functional checks are ranging from network all the way to Lighthouse here and recorder as well, if you're interested. Uh, Maybe I'll dive in a bit in another time. So what we have listed here, we have the network, we have the performance, the memory, applications, so on and so forth. The one tab that you will use the most for this, I will show you briefly about it, is the networking tab. But let's continue on so that you can follow along in the materials as well. We're going to start up from the performance. Now, for the performance, when you click on it, you will probably see these local metrics on your end as well. You're going to see largest contentful paint, so cumulative layout shift, interactions to the next paint. So maybe these are not the, let's say, um, most friendly values when you open the metric section. So what you can do is you can actually click on this little refresh here. It's already refreshed the entire page, but I'm going to show you what's going to happen once you do that. You're going to see all this information like this. So now it's a completely different layout. And what we can see here is we can see actually what we have on the page. You see we have the source, then we have Google Fonts applied somewhere along it. We have some scripts inside, renderings, painting, so on and so forth. And then when you open this window, I know it looks a bit, let's say, scary. You can see some screenshots. So this is from the page. It shows us what is the status, what we see. If there are some issues happening in between, you can see here in this window below. Then we have the network tab. We have the frames. So this is how many frames per second we can actually expect for this. Then below it, you can see some tasks that are running, some parsers. You can see additional information as well. And if you actually use the scroll on the right here, you also see a bit about the CPU information for some of the things that were happening for the GPU as well. So this is basically giving you some, I would say, not so intuitive information, but some info on what's happening with the page alongside some screenshots. Um, I would say this is not really the tab that is the most used for performance. This is something that if you're interested, you can see what is happening currently on the page from, let's say, a perspective of how many frames are loaded, if the GPU, CPU are going at a good rate. But the most important and widely used one, I would say, is the network tab. And now when you open the network tab, you're again going to see a lot of things happening right here. And the best thing is to see what is happening within the page and all the requests that are going on. So here on the left, you can see we have some CSS, we have some JavaScript, so on and so forth. They will have the status 200, 3 or 4, so it depends on what everything is. You can see what is the initiator, the size. So this is the size, for example. Here, this JSON file contains some kind of data, so it has 0.2 kilobyte of size. We have what is the time for it in comparison to the others to load up. And let me just show you briefly, if I log into Swag Labs like this, you will see that this is updated now, right? So I have all these items over here. And if I open, let's say, this item, and let's just refresh everything here, you're going to notice that we have a lot of things going on different to what we had before. So for example, you have some data, we have some preview we can do here for these items. So this is the Facebook icon. You see it has timing information. So how fast did it take for it to queue start, whether it was displayed. so on and so forth. So you can play around with these. You see that it's a PNG file, it's in memory cache, so it's going to be erased. So basically you see information about what was the time, or rather response time, so how much did it take for the resource to load, whether it was loaded as expected. So we have the status as well. We also have the name of the resource, so you can click on the name of the resources here, and if you click on them, you're going to see like the headers. So if you remember from our API lecture, we have what is the URL to get the resource, what is the method, status of that request basically, and then you have some additional information located here. And also, if you want to create your API requests when we use JMeter later on, we will use this bit, but I will show you how in that lecture, not to overload you with information. You can look at the preview, so you can see this is a style, for example, so you can see what the style contains. And then you can see the response. So what is the response is, again, the styles that we get applied, see what is the initiator or either the URL, and you can see some timing information. Again, you don't need to stress too much about this. This is usually helpful when you have, again, when you need to debug something, when you want to see where the issue might arise. You might see, like when you refresh the page here, for example, a status of 504 or 40 something, depending if it's client or server side. And then you can usually just click on the one with the issue. It's going to be highlighted in red as well, which is very nice. And then you open it and see if it's maybe something related to the request, to the response. Maybe it's something related to the timing. So you might see here that it's like 10,000 milliseconds, which is too much. Also, the way that we found the issue with the image in the scenario that I gave at the beginning was through the networking tab as well, because we saw that the image was in a JPEG format, which is a lot larger than a PNG. And then here, the memory size that it took up was in megabytes. I believe it was maybe around, I think it was nearly 300 megabytes, which is too much. And again, a lot of users, too much memory for just one image doesn't fare well. So you can use this to just basically see sizes of elements, what elements are doing, so on and so forth, how much time it takes for everything to render. You have all these options, which again, I'm not going to go too much into detail. I don't want to confuse you, just the base necessities that you're going to need. Moving on, we also have the application section. Now, this application section here, you can actually use it if you want to check something related to storage. You can select the service workers here, and when you open it, you will see you have this information about the sauce demo page regarding the service workers. So yeah, but basically you have like all data storage that you can find. Like if I click on which, you can see what keys are used inside here with the values that are assigned. Again, this is not something that you can access inside their database. This is just some data that is needed for this domain. You can also see in the other databases like this. Again, sensitive information that you will have will definitely not be displayed here. If you have any concerns for that, this is again just checking if everything is in order, and you can just browse through them. You can also open the cookies and see if there is like a session. For example, I'm currently logged in, so we can see that I have this session right here for this user, and they're stored here. When I log out, this will probably be terminated. We can also check that out if that happens. So we'll need to refresh this now. And now you see I don't have anything in the cookies. That's because I've lost the session. I've logged out. It ended. The cookie is cleaned. Everything is erased. And you can also look at other elements as well. Again, this is just to check whether the storage for that application, everything is in order, if there are some maybe missing parameters that need to be tracked. But again, this will be dependent on the project. So all you can do from here is just to try and see if you notice some inconsistencies. Maybe you will see you log out and you still have a session for the cookie here. If that happens, that is an issue because again, you don't want everything to be stored and never erased, as we mentioned before. So it's very useful to just skim through and see if you might notice any inconsistencies. Now, the final bit is Lighthouse, and some of you might have seen Lighthouse, some of you may have not. This is basically a reporting tool. that was added by Google. It's fairly new. Me personally, I rarely use it. I don't really, as I mentioned, I don't really go through these items when I'm uh, running my performance tests. I just use the network tab to find what is an issue that has occurred. But if you want to play around and learn a bit about Lighthouse, you can open the tab. Again, it's in the inspect element. You can click on Analyze Page Load here, and it's going to basically give us some information from the performance of this page overall. So you see it's now working on it. It's going to take a bit of time, and it's going to give us a score. So we see what is the URL. We see performance-wise, it's a 99 out of 100. Accessibility is great. Best practices not ideal, and then SEO 63, and then gives you some metrics. So you see first content paint 0.7 seconds, largest content paint 0.9, total blocking time none, cumulative layout share none, speed index 0.7, all fairly good informations. And then we see render blocking requests. If you open it, it gives you some information regarding what items are potentially causing some issues. You can open it for each of these here. And then, yeah, you can just go through all the results. You can also click on these items here. They're like anchors, and they will give you um, additional information as well. So you can open it here. Again, this is just if you want to play around and read more about the performance. Many times on projects, you might see maybe even less score on accessibility. Maybe on practices, you will see 60%. You don't need to be too much worried about this. This, again, is a tool generated by Google to use. I strictly prefer when doing these parameters and percentages of how many best practices are implemented and added, I would rely on developers' expertise as well as the results from testing tools, not so much from Lighthouse. I see there's a question from Inas. Why would the analysis be different on different machines? Um, it also plays a part when you're trying to do these kinds of tests, how good your connection is sometimes. For example, I was having some network issues earlier, so sometimes I might have less accessibility. Sometimes my network might also be causing some issues, so I might even not be able to visit the page. So in the networking tab, you're going to have something completely different from what I'm having, for example. So personal network is also something to take into consideration when running performance tests, as well as the machine you're running them on. Thank you for the very good question, Ines. I also want to mention that when you're doing performance tests sometimes and you're running them, let's say in JMeter, when you run them on your local machine, it's also going to take up your resources because what you're doing is you're effectively simulating, let's say, 1,000 concurrent users. If you do, there is a little math that needs to be done to calculate the total number of users, but let's say 600 concurrent could mean 40,000 total users. So imagine you're simulating a load of 40,000 users from your local machine, and it's eating your RAM, your memory, your network capabilities, and everything. So it's taking a toll on your machine. So you might see some things that you might not expect to see from another perspective. So imagine you open the page while you run the tests on your end, and I'm opening the page while I'm not running anything. Obviously, I'm going to more easily reach the page first, and also you might not have the best network access due to you providing so much to all the simulated users. So it does take a toll on the machine that it's being run. That's something to take into consideration. So that's why you have separate environments, usually on virtual machines, so that your own machine is not affected by this. But yeah, so you could actually see some differences. But usually the differences should not be large. For example, it should not be if the case is, for example, let's say Ines, you are on the page, and then I have also fine good network connectivity. If I get 504, but you are able to visit the page, it's an issue. So it should not be the difference that the page is crashed for me, but it's okay for you. If the difference is for you, you have 350 milliseconds response time. I have 370. It's negligible. It's maybe you have a faster network. Maybe I have optic cable. Who knows? But usually you won't have so much difference in the difference in the network parameters. hopefully that answers the question. Okay. Yeah, and basically that's what you can expect to find within these dev tools and such. As I mentioned, this is a personal preference. Again, um, every tester has their own approach. Maybe you will find Lighthouse to be your approach to check out things. You will probably want to see and read more about in the details provided here that you get from the results. Maybe you're a person who likes to rely more on the performance tab. Maybe you find it more easily understood, better to read with some facts. I personally use the network tab for checking some stuff when there are some issues regarding performance or when we think it's something performance related, because again, you will see it here when I'm hovering, usually when there's an issue. And in addition to that, it's very intuitive when you find it because it usually is highlighted red. You see that there's an issue, you open it and it gives you the details there. So quite simple, and it gives you all the information you need. You have the resource, you have the response, you have who's the initiator, you have the size, very important, and the time, the response time. So basically everything you need for output, time, response time, status, everything is displayed here. So my personal recommendation will be to keep this when you want to do some debugging or find the root cause. Okay, do we have any questions for this section so far? Okay. If we don't have any questions for the Chrome DevTools for performance testing, I think we can move on to the hands-on lab right now, which we will do on web page test. So what is web page test? It is basically a free performance testing tool. It's not the most, let's say, in-depth performance testing tool from a parameter standpoint, but it's a very good tool to sometimes show some maybe underlying issues that you will not be able to catch so easily. So basically, this is like, imagine it like a built-in DevTools combination of the networking, the performance, the application, and the Lighthouse, let's say, tab from the DevTools. So it has all of them in one, and it gives you some very fine details, I would say. It also supports multi-location testing, so you can test it from various geographic locations, which is very a neat feature, so you can see what's happening with different connections. You can maybe see how the internet will behave or how the performance will be from a different country, which can vary, of course. Has real browser testing, so it's done in a real browser. It's not something that simulates some environment where it performs the test. So it can be done Chrome, Firefox, Edge, so on and so forth. The best part about it, it gives you very detailed metrics. So all the data that you will need, you will see as presented here in the window, which is very helpful. So we will go through these in the lab exercise itself. And then it has a few views. So we have this one is like the general one that you will see when we run the application. Then it has this waterfall view. Again, takes some parts from the DevTools. So this is the performance tab that we saw earlier. You can see a breakdown of all the requests that are made when something is loading. You have a film strip view, which shows you like screenshots of the page, so what is happening, a visual progression. So maybe sometimes if something fails, you will see in an image that somewhere something is maybe tweaking, something might be causing an issue at a given point. So very useful to have that as well. And it gives you some suggestions similar to Lighthouse. So that's why I mentioned it's like the tabs from DevTools into one, where you just paste the link and see the performance overall. It's very neat. It's a very useful tool, and most of the time it's just used for debugging when it is used. Uh, from a project perspective, again, we usually use the network tab only, so we can see and debug and find root causes there. But we have used web page test a few times to just see what we can enhance, because it does give some good suggestions, and sometimes you might not be able to get to the solution without getting some suggestion online and then working with that. So without further ado, let's dive into the web page test. So we will be using the example.com page link, which I'm going to copy and paste in the chat. You can use it as well. We can also do another page if you all want to do it as well later on. You can actually use, we can actually just use the our own browser. So I know there's a section here for the VM. You can just use the browser for this. This is a tool that's open source inside the browser, so we don't need to use VMs here. And I'm just gonna open it. You can use this link, which I'm also going to copy and paste inside. Yeah, Jumana, you highlighted the VM is usually slower. Yeah, I agree with that. I think at least for this exercise, we don't need to do it on the VM. Again, it's quite straightforward. We can do it on the browser, secure as well. And now, when you visit the link, you're going to get this page right here. So you should see something like this in the layout. Um, what functionalities you can notice here are that we can select the region, which is US, Europe, or Asia. We can also select the device, whether that's a desktop or a mobile, and then the connection type, which is regular 3G, fast 3G, regular 4G, regular 5G. So we can do all these options basically. And then you have the place where you need to input your link, which will be example.com. I've played it a few times already, so it's already saved on my end. And all you need to do once you've done this is just click start testing. Now, no, mind you, this page has been updated, so now we might have to wait for a few seconds, maybe a minute, minute and a half. You might notice if you're trying it on your end that you might be put in a queue. Again, this is due to the catch point page. It has some limitations to how many users can actually use this at a given time. So if you see something like in queue, it just means you have to wait a bit more than someone else. Um, but otherwise, it will still get the results that you need quite fast. And again, as I mentioned, this is mainly a tool used for checking overall performance of a page. If you want to double check something after you've done your tests, you can use it mostly for debugging. So if you can't find maybe a specific solution on how to enhance performance, it gives some suggestions, which are, again, sometimes very useful. You can work with those suggestions, and we will see just that once this is loaded. And while this is going on, we can follow, I can show you the steps. So again, you can use the URL that I pasted in the chat. You can set whichever location you want. You will most likely have a different result if you set it other than the US from me. For now, the browser is default Chrome because we're using Chrome. If you want to use Edge, you can just run the application from Edge. Then we have desktop. You can use mobile. Again, it's all up to you. And then we run the tests, and then we will analyze what we have inside. Okay, so we have the summary. Some of you might still be waiting. It's perfectly fine. If you want, you can just go through it on my screen. So we see we have the URL that we used and then the configuration. So we used Chrome, the version of Chrome. We see that we were using Wi-Fi, and then we also were from the location in the US, Los Angeles, and then the runtime displayed here. The first thing you will notice, it has some, let's say, fairly straightforward summarized information. So is it quick? Looks great. Site was quick to connect, so on and so forth. Is it usable? Looks great. This site has good layout, stability, looks to become interactive. Is it resilient? Site had no render blocking third-party requests. So these are basically a summary of the most important aspects of the page. So when you see that everything is good with these, this usually means that you're very unlikely to have any issues with the page performance-wise. So again, we are testers, so we'll try to debunk this, but these are fairly good indicators, I would say, and good summaries that we can read on. Now, when you go down, you will see some additional parameters like time to first byte, which is the time that you need to basically get the first piece of information onto the page. This is a start render, conditional paint, largest conditional paint. So again, This is basically information about the time of all the things that did to load throughout our page. And the good thing that you can find here is you also see screenshots of the URL, which is nice because we can also see, okay, the page is actually loading. Because imagine a scenario where the page is not loading, but we, for example, get false positives, if you remember from one of our lectures before. And the false positive was when everything might be working good in the test part, but it's actually not. So the good thing with the screenshots is you can actually verify that the actual page is loading. This is what we need to see from example.com. Then you have the individual runs here. So you see the render start 100, 108 document completed, largest contentful paint, so on. A thing that also might interest us from here would be film strip. So this is the screenshot part that I was talking about. Why is it important? It's important because, as I said, we want to make sure that what we are actually running is working as expected. So we don't want the content to be empty. We want the content to be present, not just the page to exist. Then you can open up the performance. Again, you will see a lot of these information here. So these are basically just additional information for your page. We have the waterfall view, so you can see it's again similar to what we looked into the performance tab. You see that there are no additional issues from what is shown here. So everything seems to be in order. So you see there's the amount of JavaScript, CSS, images, Flash. You see how much time it took for them to be executed, all fairly low. So there was no issues in them happening throughout the page. That's basically what you find here. You can also find it in this window, the waterfall, if you want to have a bigger image of it. You can see how the CPU was utilized here. So we can notice here in the graph, it needs to be utilized right around the first millisecond here along when probably the pages start to load and all the items within it, but this is still fairly good. We don't see any spikes. We don't see the CPU going crazy at any moment. Usually when you have issues, you will notice that the, let's say this line that is represented with do insane spikes up and down. But yeah, basically this is what we can see from the results here. You have some assets and then JavaScript. Again, this is not uh, some too much in detail information that you will need, because you see here it just gives you information on what kind of JavaScripts there are. Don't need to worry too much about them at this point in time, but again, some useful information is provided. I see from Juman in the chat, any websites you folks are interested in testing out after learning about web page test.org? If so, which ones? No, that's a very good question. Do you want us to try and run any other page right now? Any page you can think of. Again, we can do it with all pages. So because example is a fairly straightforward, this one just follows what we see. I, for one, would probably want to do one of the more bigger pages. For example, we can do Amazon. If you want, we can try and see what happens with Amazon. So I can open it here. We're gonna paste it inside the URL here, and we're gonna let's put a 4G. I don't have 5G, so let's say 4G is something that interests me, and I'm using mobile. So let's do a bit of a different test this time. So I'm gonna change it to mobile, and I'm gonna set to Europe. So let's see what happens now. Let's see what are the results. And you can play around with many pages like this. It's quite fun. And again, you don't need to stress yourself too much about these results that we get here. Again, uh, what we're most concerned with is our monitoring that we will get from our applications that we use when monitoring. And then these are more used for debugging or finding some root causes. So, and again, this will take a bit more time than you expect. So you can also see if I go down, So this is a bit, some parts are from the older version. This page actually gets updated without notice, so you might notice changes here and there, but yeah. Let's see, okay, fairly fast. So we got the information. So let's see what we see now. Is it quick? It says not bad. The site took little time to connect and deliver initial code. Began rendering content with delay. There were one render blocking request. So you see previously on example.com, everything was smooth. So we got great. Same goes for usable. This site had good layout stability. It took to become interactive. Some HTML was generated after delivery. So you see something came after something else. So it didn't generate at the same time. You also see it in a screenshot here above. The site had render blocking third-party requests with a single point of failure, had no security issues. Again, the HTML issue, we can notice it here. So basically, again, we get this information summarized, which is wonderful. Then we see what we were testing at. We can see iPhone 15, Chrome version 136. And then don't be confused also by this. This is Chrome because this is the browser I'm using. It's not Safari because I'm working on Windows, so I don't have access to it. If you try it, I don't know if it works with Safari, but if you have a Mac or an iPhone, you can try for that. You see the information is going from Amsterdam and then all the megabits, 9 megabits per second with the 4G. And then if I scroll down, we see now in comparison to the previous run, we have a good result for the FCP, for the first connectable pane. So for the first item to appear, we see it's 1.20. It shows that uh, it's good. So it's not great. Previously, we had less than 1, which is amazing. Same applies for the others. We can see that there are differences than the others. And then for the time to before anything was rendered, for the first thing to appear, it's 0.81, which needs an improvement. So uh, again, it gives us this information. We can work around it. So maybe a developer would see this. We'll try to see if they can optimize it. Again, this is not bad timing for the first byte, but again, it could be improved. And maybe there's some HTML element that can help us with this, that can't, but you know. Then if we go with film strip, we can actually take a look at the screenshot. So we see it's in a mobile version, it's simulated. We're on the Amazon homepage. We can see what was happening there. If we open the, I prefer the waterfall, we can see what was going on with all these items here. So you can see the HTML that we're talking about happen here after the first second, which should usually happen before, so everything should be loaded at the same time. We can see it took a bit more time than expected. Some DNS connection items going on here. So you can see how all of them appeared at which time interval. And then if we go to the waterfall here, we can see the CPU utilization. So you can see previously we only had like a fairly straight line, which only peaked at about the end, but nothing special. And here you see how the CPU behaves. So it needed a bit more power at the beginning. Then when content started to load, it starts to increase. So this is around the part where the HTML started to appear. Then when all the other events happened, again, it picked a bit of bandwidth you see here because again, due to the connection. And then you see there are some smaller changes, but it was able to handle everything. And again, this is something you can follow inside Task Manager, inside your third-party software for performance testing, but it's good to note these things here if you need to do some debugging. And if you open here, you'll notice we have a lot of JavaScripts. So we have for layout, evaluate script, function call. You see a lot more information than we previously had. And obviously, because we're going on the Amazon homepage, so there are a lot of items and connections of databases and everything there. So obviously, we'll have so much more information provided here as well. And that's about it. Well, in a nutshell for this, do you have any maybe questions here that you have for the web page test? Any information that you want to know more, or I'll mention this again. So this is mostly for debugging or finding some root cause, ideas on how to fix those issues. So um, it's not the, I wouldn't say it's the primary tool for testing, but it's good to know. Very, very handy. Okay. If there are no questions, I'm going to go to the last bit of today's lecture, which is the practical implications. So basically, how does it impact the world when we do performance testing on our apps? Well, um, we've already talked about why it is so important, so I'm just going to try to keep it as short and sweet as possible. User experience. We want users to be able to use our application as simple as possible, as fast as possible, so there are no delays, there's no lack of content. So when they open the pages, they're briefly welcomed into something that's optimized, into something that is high in performance. So even us as testers and users of other applications, we expect that. So we should always have in our mind that this is what is required for the users of our software. In addition to that, they should be reliable, stable, scalable. Meaning, when I use the application, it doesn't work too fast one time and then slows down in another, or when there's peak hours, but it should be stable and running at the same speed that we have developed across the life cycle of the development, and it should be scalable. So if more users come, nobody should notice that it has slowed down or if it's increased speed when there are less users. So it should scale up and down appropriately so that this flow is in a way um, constant, let's say. And I would add uh, cost efficiency and competitive advantage. So when you find these performance related issues early on, and why you should find them is again cost efficiency. You want to make sure that you have as little as possible issues happening on production performance wise as well, since they will need less cost to fix in the earlier stages and will require less time to waste when you get to the production environment and everything needs to be retested as well. And also competitive advantage, the more stable, the better performance of your page, the better you are against your competitors. So if you have a page that, let's say, goes toe to toe with Ticketmaster, and when a big release comes into play and you're able to basically go through everything and provide, let's say, the tickets and the items that people want to buy without any issues, you will definitely have the edge over your competitor. Now, why it is also um, uh, important to have the performance testing in CI/CD pipelines, and I would say in specific cases when you're doing it so and you have the option to do so. Early detection issues, as I mentioned, you can set up something where you run performance test after code changes. So for example, you have a 2 week sprint, it ends, everything is merged, and you run performance tests. Same happens in 2 weeks, or maybe you want to do it weekly, maybe you want to do it daily. Once you do that, you have early detection of issues and you make sure with every change your code and your page are stable. Continuous monitoring. So you will have some kind of report at all times. You can compare it daily, you can compare it weekly, bi-weekly with the previous results, and you might even notice, even if the results are successful, if there's something lowering the performance. So you can immediately take action for that. So you can say maybe in the next week, the performance for some parameters was at 97%, previously 99. So you can check if there is something causing this decline. Maybe a larger decline will happen with the next merge. So you want to make sure that this result is steady. So continuous monitoring also is supported. It automates the testing process, so you don't have to rely on you setting up and running the performance tests once during a release or every 2 weeks. So you don't have to log into the server, click run on the test, run them through a PowerShell, and then just do all the process, which can be annoying at times. Having an SACD, it is automatically trigger run. All you have to do is just monitor the process. Then we have consistent performance standards. As I mentioned, if you have the constant output of results that you want to have, so let's say you have managed to find a lot of issues, mitigated them, resolve them actually, and you have this steady flow of always getting a very good throughput time, you have a very good response time, so everything is in check all the time, means that your application is consistent and it will turn to do so when going to larger environments. Finally, risk mitigation. If we are able to have a standard for how good in performance our page is, we will obviously have less risks, we will have less issues. And again, reducing cost, having an efficient web page, and also being able to um, give the best that we can to the users of the page. So again, it's very useful to have it in a CI/CD because of these reasons. But even if you don't have it, there are ways to implement performance tests without the CI/CD, although you have to do a bit of manual prep. But again, I really do recommend doing it as soon as possible and, if possible, as frequently. So, in a nutshell, shift left promotes both functional, non-functional, and it just depends on what kind of project you have the opportunity to do one or the other. All right. Do we have any questions? I don't see any questions inside the chat, so I'm going to now, let me just find the Kahoot. We're going to do a little Kahoot right now for the intro to performance testing. So let me just pull it up. There we go. Just going to, you should be able to see it right now. Okay, you can join using the game pin on the screen here. And we can do the brief Kahoot. Thank you, Jumana, for sharing the pin and the site for it. And you can all join in right now. I see some of you are joining right now, so feel free to get into the Kahoot and to write down the code so we can start it. They're all in the chat. You can also see them on my screen. So let's get into this Kahoot, do a bit of revision on what we studied today, and yeah. Also note we'll do a bit more practical part in the next lecture with JMeter, which is also very nice. So this was a bit more theoretical, but we need to also practice a bit of theory before we go into the hands-on. I know this is a bit more of a talking lecture, but you'll see that it will be helpful for both when you continue on testing and the next exercise. Right? I see more people are joining. I'll wait for a brief minute before we start. If somebody else wants to continue and join, and then if not, we're gonna start it. Okay, I'm gonna start the Kahoot now, so you can all get ready, and here we go. Let's see what the first question is. What indicates failure in stress testing a bank's portal handling a massive surge in logins during a stock market crash? So what is the failure? Okay, I see some answers for login attempts are delayed, but no errors occur. Uh, well, there aren't, the pages do technically load and there are no errors. I mean, the login attempts are probably a bit delayed, but this is not really due to a result of just having a bit more users than expected. So this would not be the ideal answer. We also have a few answers for server resources are maxed out but stable. Um, this is basically more of a scenario for when you finish the stress testing. So this is what you want to expect for certain degrees, but this is not a failure that is indicated because again, it is stable, so there's no failure here. And then the answer that we're looking for is pages load with incomplete elements because when something is missing from a page, that shows us that we have an issue. So we see an error, we see that no elements are displaying which are supposed to be displaying, so this indicates some kind of failure. In these other two answers, we see there are no errors and the page is stable. So everything is okay, even though there are more attempts and there are more, the resources are maxed out. So the answer would be load with incomplete elements because again, there is an issue here. All right. I'm sure that you'll do better than the others because this is a bit more tricky Kahoot. Let's move on. Your team is simulating heavy traffic on a streaming platform. Which tool would be best? So heavy traffic on a video streaming platform. You might know some of the other tools as well here. So wonderful. There we go. Well, we got the right answer, JMeter, with again the tool that we will be using next lesson. The others, obviously, we haven't touched on. And Selenium, we said absolutely no performance test. So good job to everyone. Let's move on to the next question. Which performance test simulates sudden increase in user load? So sudden increase in user load. Wonderful. I see the majority answered spike testing, and that is correct because the keyword is sudden increase. It was just increase in user load. It could be load testing, but it's just sudden increase. So it's just a brief period of increase like a spike. And then scalability is to see if something can scale up or down. So if more users come, the page is optimized to handle more. If less, it downgrades. And then stress testing was only going above and beyond what can be accepted. So again, good job to everyone. You're testing an e-commerce site during a major sales event. What should you ensure to simulate real-world conditions? So what would you ensure to simulate real-world conditions? So which one do you think makes the most sense? Wonderful. I see nearly everyone says server load matches expected peak traffic, which is correct. It's a major sale event, so it's expected to have a lot of users that day. And then for discount codes are correctly applied, this would be more of a functional test for that bit. So the answer is C because again, this is non-functional, what we're looking for. But still, it is that should also be applied from a functional perspective. Let's see. Which performance testing type evaluates how well the system scaled with increased load? Let's see. So how well the system scaled with increased load? I see more or less everyone has answered. And let's see if it's correct. I see most of you had scalability testing. That is correct. Again, as the name suggests, it scales with increased load. So it is scalability. Load was just testing the larger load on the page. So when there are more users on a given page, and volume testing was connected with testing how much the databases can handle. Again, still very well done for everyone. Let's move to the sixth question. A retail site slows down when too many users check out at once. What's mostly like the issue? So what is the issue most likely? I see most of you said database connection limits, and that is correct. So it's again to do with with the data. So a lot of people are checking out with their items that they've chosen. So it's obviously something related to the database. And then card validation time. It's again, the card could have an issue with the validation time, but we're talking more to a vast amount of users, and the cart itself is not something that should be too much related to all that amount of users using it. It's like a separate component. So it's again not really the main focus of what we're looking for. But again, it's a trick question. So again, well done to everyone. We have 4 more questions to go. A food delivery app crashes when too many users log in. What type of testing is needed? Wonderful. So everyone went for stress testing, self-explanatory. The others are basically, let's say, functional and usability is just separately used but by stakeholders. So very well done by everyone once again. We're near the end. What type of performance test checks the system behavior under extended use? So under extended use, I would say keyword, key phrase. That was a very rapid answer I see from everyone. Let's wait a bit more. Wonderful. Everyone went with endurance testing or soak testing, and that is correct. So the more time, the stress that we handle is related to endurance testing. More time, and then the amount of users is it differentiates depending on the needs. So well done. Let's wrap up with the last 2 questions. What is common use case for load testing? So what is a common use case? As she mostly went with simulating 10,000 users. That is correct. It's a large load of users on a page given a period of time, which is correct. And then testing the system's breaking point is related mostly to stress testing. So we want to see where it breaks. It is stress testing. That's how we differentiate both of them. Let's finish the last question. You're testing an AI chatbot handling multiple queries. What is the key factor to validate under load testing? So to validate under load testing, I see a mix of answers. Time to respond to each query is correct because we want it to give the answer to everyone. Accuracy of responses is actually a functional test. So to check whether it gives the actual correct responses is something we want to check with our maybe end-to-end test when we write some prompts to it. So this is more of a functional aspect. And then memory usage by the chatbot. Well, it's not really the interest of load testing. So we can probably do that with endurance. We can do it with volume testing, and then user interface responsiveness. Although it is important, uh, it is not what we're aiming for the chatbot specifically. So it handles multiple queries. So it is basically something that we're communicating with. So if the interface is not as responsive, but we still get the answer, it still is not very, let's say, it's not under our scope of testing. So the ideal one would be time to respond to each query. So if 3 of us write to it, we want to see how fast it answers to all of us. But nevertheless, good job to everyone. In the interest of time, I will stop now before we see the podium, but let's do it. We still have a minute. Good job to Binu, Inas in second, and then we have in first place for today. See, Valentina. Congratulations to all of you basically who took this Kahoot. Thank you very much for taking part in this lecture. We will have more hands-on practice with JMeter in the next one. And yeah, that will be all from my side. So yeah,